Welcome to the DIY Honda Garage channel. This presentation addresses DTC P0133, which refers to a malfunction or slow response in the AF sensor, also known as Air Fuel Sensor 1 on Honda CRV models from 2011 to 2016. The AF sensor is an essential component that measures the ratio of air to fuel in the engine's combustion chamber. This information is crucial for the Engine Control Module, ECM, to optimize engine performance and reduce emissions. The sensor is positioned in the exhaust stream before the catalytic converter, where it can accurately gauge the exhaust gases. A malfunctioning sensor can lead to poor fuel economy, increased emissions, and overall engine inefficiency. Understanding this DTC is vital for any technician aiming to restore vehicle performance and ensure regulatory compliance. DTC P0133 indicates a malfunction or slow response from the AF sensor, specifically Sensor 1. The AF sensor plays a crucial role in maintaining the correct air-fuel ratio, which is vital for optimal combustion. It is situated before the catalytic converter in the exhaust system, allowing it to sample exhaust gases directly. By detecting the amount of oxygen in the exhaust, the sensor provides feedback to the Powertrain Control Module, PCM, regarding the engine's operational efficiency. If this sensor is malfunctioning, the PCM cannot accurately adjust the fuel injection, leading to either an overly rich or lean mixture. This malfunction not only affects fuel efficiency, but can also increase harmful emissions. Regular monitoring of this sensor is essential for maintaining overall vehicle health and performance. There are several possible causes for DTC P0133. First, a faulty AF sensor is the most common reason, where the sensor may fail to respond accurately due to internal damage. Wiring issues between the sensor and the PCM can also contribute. Frayed or shorted wires can disrupt signal transmission. A bad connection at the PCM or sensor terminals may lead to intermittent errors, which could cause the DTC to appear. Additionally, any exhaust leaks can falsely alter the sensor's readings, making it appear that the sensor is malfunctioning. Overall, a thorough inspection of the sensor, its wiring, and connections, along with checking for potential exhaust leaks, is crucial in the diagnostic process. When DTC P0133 is triggered, several symptoms may arise. One of the most noticeable is poor fuel economy, as an incorrectly functioning AF sensor can lead to an improper air-fuel mixture. This can result in the engine burning more fuel than necessary. Increased emissions are another key symptom. The vehicle may fail to meet emission standards due to an improper air-fuel ratio. Additionally, drivers may experience various engine performance issues, such as rough idling or a lack of power during acceleration. Furthermore, the check engine light will likely illuminate on the dashboard, signaling the driver that attention is needed. Awareness of these symptoms can aid in the early detection and resolution of the issue. The first step in troubleshooting DTC P0133 involves verifying the issue. Begin by turning the ignition switch to on position 2, which powers up the vehicle electronics without starting the engine. Next, clear the fault codes using the Honda Diagnostic System, HDS. This step is critical to ensure that you are working with a clean slate. After clearing the codes, start the engine and hold the RPM at approximately 3,000 without any load until the radiator fan activates. This action helps to simulate conditions reflecting real-world driving, allowing the system to recalibrate. By closely monitoring the situation, you lay the groundwork for further tests and observations that might elucidate the problem further. Step 2 involves preparing the vehicle for a test drive to observe its performance under specific conditions. Ensure that the engine coolant temperature, monitored via the engine coolant temperature sensor, exceeds 158 degrees Fahrenheit or 70 degrees Celsius. This is important because sensors often rely on the engine being at a normal operating temperature to provide accurate readings. Put the transmission into drive, allowing for more natural driving conditions. As you drive, maintain the engine speed between 1500 and 3000 RPM, which mimics various driving scenarios and loads. During this time, it is crucial to monitor how the vehicle behaves to gather informative data on the AF sensor's performance. The third step is to follow specified driving conditions that will facilitate the assessment of the AF sensor's functionality. Initially, drive the vehicle at 25 miles per hour or 40 kilometers per hour or less for 5 minutes. This low-speed section allows for initial data collection and lets the engine operate under low load. Afterward, increase your speed to a steady pace of 32 miles per hour or 52 kilometers per hour or more. Maintaining this speed for a while is crucial for observing the sensor's response under different loads and operating conditions. During this test drive, continuously monitor the onboard diagnostics (OBD) system status using the HDS to check for indications of DTC P0133 and any possible changes in readings, which help to evaluate the sensor's current status. In Step 4, continue monitoring the OBD status for DTC P0133 using the HDS. The diagnostic system will help determine whether the AF sensor is functioning as expected. If the HDS indicates failed, it's time to replace the AF sensor, Sensor 1, since this failure suggests the sensor can no longer accurately monitor the air-fuel mixture. However, if the HDS indicates passed, further investigation is needed. It is crucial at this point to check for loose connections or poor terminals at both the AF sensor and the PCM. Intermittent failures often hint at underlying connection issues, so a meticulous examination of wiring and connectors may reveal the root cause, helping ensure that all electrical connections are solid. Final repair verification is essential to confirm that the troubleshooting and repairs have been effective. Begin by turning the ignition switch to on position 2 and then resetting the powertrain control module, PCM, using the HDS. The PCM is the brain of the vehicle, managing all aspects of engine performance, and resetting it ensures that it adopts any new changes made during the repair process. Next, perform the PCM idle learn procedure. This process helps the PCM relearn idle settings for optimal engine management. After these steps, monitor the OBD status again using the HDS, ensuring that no DTCs are indicated. A successful pass result signifies a resolved issue and confirms the effectiveness of your repair, thus maintaining the vehicle's performance and compliance. Preventive maintenance is critical to avoid future occurrences of DTC P0133 and other related issues. Regular inspections of the AF sensor can help detect problems before they become serious. This involves checking not only the sensor itself, but also its wiring and connections to ensure they are free from corrosion or damage. Keeping an eye on overall engine performance also plays a major role. Be vigilant about any changes in fuel economy or engine response. Additionally, it is essential to keep the exhaust system in good condition, as leaks can compromise the sensor's effectiveness. By adopting these preventive measures, vehicle owners can significantly minimize the risk of sensor-related problems and maintain optimal vehicle performance. In conclusion, DTC P0133 represents a malfunction or slow response of the A sensor, a critical component responsible for ensuring optimal fuel efficiency and minimal emissions in Honda CRV models from 2011 to to 2016. Understanding the role of this sensor is crucial for proper vehicle maintenance. Regular monitoring, thorough inspections, and prompt troubleshooting can mitigate the risks associated with this error code. Following the detailed troubleshooting steps methodically ensures a clear path to diagnosing and resolving issues effectively, leading to a well-functioning vehicle. Implementing preventive measures can further extend the lifespan of the A sensor and enhance overall performance, highlighting the importance of diligence in automotive care. Please like and subscribe to the channel. See you next time.